In a very important way, we've actually been seeing residuals this entire class. A residual is just observed minus my expected. So notice that in reality, all this is like x bar minus mu naught, or p hat minus p naught. I've been calculating these residuals the entire time I run a hypothesis test. For a regression line, I use a little bit of a different symbol though. My observed value is actually y, and my expected y hat. So talking about regression equation, I take y minus y hat. Let's go ahead and look at an example. Now, for the last video, we had y hat equals 4.5 plus 12x. I want to know, if I give Kobe 4 pieces of cheese, how many minutes would I expect to get? Now, the important thing to realize is I'm not probably going to get exactly this many minutes. This is just my expected value. So, plugging 4 in there then, I have y hat equals 4.5 plus 12 times 4, which will give me 4.5 plus 48, or I believe 52.5. So if I give my dog 4 pieces of cheese, I'd expect to get almost an hour of his attention, or at least him tolerating me. Now, in reality, let's say Kobe leaves after 30 minutes. Was my prediction accurate? Well, I thought he'd stay for 52.5. He only stayed for 30, so not particularly. I can measure exactly how accurate it is by calculating the residual. To find the residual, I'm going to take y minus y hat. That is my observed minus my expected. Well, my observed is how many minutes he actually stayed, which is 30. My expected is the estimate I made, which is 52.5. So I'm just going to go ahead and take my actual minus my expected. And when I do that, I get negative 22.5. It's negative, which tells me what I expected was actually higher than what actually happened. Or rather, my actual was lower than my expectation. Remember, this is what happens with z and t scores as well. I get negative z and t scores whenever my observed is below expected. I have a residual of negative 22.5 because I actually fell 22.5 below my anticipated value.